Good morning, students. So in last class we have done about the chemical reactions of alcohols, and I have given one mechanism also. That mechanism was very important, and I have given one question also, but no one give me the answer. If you cannot write the formula, just you write the name of the product and you tell me what will be the name of the product. So after that I will tell you the answer. So next reaction, I think this will be number 6, oxidation reaction of alcohols. Oxidation reaction of alcohols. So this is one alcohol. I have considered ethanol. When you do oxidation in presence of some oxidizing agent, then what happen? Oxidation means either addition of oxygen or removal of hydrogen. In alcohol, when you do oxidation, first time hydrogen will remove, not the addition of oxygen takes place. Already oxygen is present, that's why they have the tendency to remove hydrogen. So how the hydrogen will remove? One hydrogen will remove from this oxygen, this hydrogen will remove, and another hydrogen will remove from the carbon. Two hydrogen will be released, one from this carbon, another from this oxygen. So ultimately you will get the compound CH3CHO, which is said to be aldehyde. And that is why when you oxidize alcohol, always you will get aldehyde, or it may be ketone depending on the nature of alcohol. If you take this one, CH3CHOH CH3, its name is propane-2-ol. Propane-2-ol. The difference between this one and this one is, this is one example of primary alcohol, this is one example of secondary alcohol. When you do oxidation, then here also this hydrogen and this hydrogen will remove. After removing this hydrogen, you will get the compound as CH3C double bond O CH3, which is said to be ketone. So if your alcohol is primary, you will get aldehyde after oxidation, and if your alcohol is secondary, after oxidation you will get ketone. So primary alcohol gives aldehyde, secondary alcohol gives ketone on oxidation. Again, you can do further oxidation also for aldehyde and ketone. When you do again oxidation for aldehyde and ketone, they will convert to carboxylic acid. Here how many carbon? 2 carbon, so you will get 2 carbon carboxylic acid, CH3COOH. Oxygen will be added. And in case of ketone, when you oxidize it, the compound will break in this position always. So this side contain 2 carbon, this side contain 1 carbon. So that is why you will get 2 carboxylic acid, this side 2 carbon carboxylic acid, and this side 1 carbon carboxylic acid, like this. This is called ethanoic acid, this is called methanoic acid. Acetic acid and formic acid, common name, and IUPAC name ethanoic acid and methanoic acid. So alcohol on first oxidation it gives aldehyde or ketone, and on further oxidation it will give carboxylic acid, and that is why aldehyde and ketone, they are called first oxidation product of alcohols. So always remember, when alcohol undergo oxidation it produces aldehyde or ketone, and on further oxidation aldehyde ketone gives some carboxylic acid. This is one ketone. If you want to do oxidation, in this position always you break, like this one. This side contain 2, this side also contain 2. Ultimately you will get 2 carbon carboxylic acid, and both sides same, that's why you can write 2CH3COH, 2 ethanoic acid you will get. So this is about the oxidation reaction of alcohol. Now another reaction, this is number 7, catalytic dehydrogenation. Catalytic dehydrogenation of alcohols. Achha, before doing this reaction, I want to tell you something. As I have mentioned, when you do oxidation, always it requires some oxidizing agent. Oxidizing agent helps in oxidation. Now, what type of oxidizing agent you use in these reactions? Now, since here two-step reaction, in first oxidation you will get aldehyde ketone, and in second oxidation you will get carboxylic acid. That is why if you want to stop the reaction in this position, I mean in aldehyde or ketone step, if you want to finish the reaction, then always you have to use some weak oxidizing agent. And instead of weak, if you apply strong oxidizing agent, directly you will get the carboxylic acid, I mean the last product. So that is why when you apply oxidizing agent, you should know whether you are applying strong or weak oxidizing agent. So some oxidizing agent example I give you. These are some oxidizing agent. One weak oxidizing agent example, if you want to apply weak oxidizing agent, chromium oxide is one of the example of weak oxidizing agent. PCC, which is called pyridinium chlorochromate, that also acts as weak oxidizing agent. And that is why if you want to finish the reaction in this step, always you use this type of oxidizing agent. And similarly, if you want to apply some strong oxidizing agent, you can apply potassium permanganate. This is one of the strong oxidizing agent which is normally used in organic reactions. And potassium dichromate K2Cr2O7, these are the example of strong oxidizing agent. So that is why you should know when a reaction contain potassium permanganate above the arrow, that means it undergo oxidation, because potassium permanganate always acts as oxidizing agent. So from the reagent, you should know what type of catalyst or what type of agent they are. So these are the example of oxidizing agent. So now catalytic dehydrogenation of alcohol. You know, hydrogenation means addition of hydrogen. Dehydrogenation means removal of hydrogen. I mean you have to remove hydrogen from alcohol. So it is also like oxidation, only the difference is in oxidation we use some oxidizing agent, and in catalytic dehydrogenation you have to use some catalyst which can remove the hydrogen. One of the dehydrogenating agent is copper, and you have to apply heat also, 573 Kelvin. So when the hydrogen is removed from this oxygen, one hydrogen removed, from this carbon, one hydrogen removed, you will get the aldehyde as the product, and the side product hydrogen is removed from the compound. Similarly, if you take some secondary alcohol, propane-2-ol, when you apply copper 573 Kelvin, then here also hydrogen will be removed and you will get the ketone as the product. This is called acetone or propanone. So when you do dehydrogenation by applying some catalyst, then also you will get aldehyde and ketone. It is like to be the oxidation. The difference is in oxidation we use some oxidizing agent, and in catalytic dehydrogenation we use some catalyst to remove the hydrogen. Products are same in both the cases. So this is about oxidation and dehydrogenation. This is one of the tertiary one. If you want to know about tertiary, since it is tertiary, when you do dehydration, here dehydrogenation do not take place, because this hydrogen you can remove, but this carbon do not have any hydrogen. So that is why dehydrogenation is not possible here. So that is why instead of dehydrogenation, it undergo dehydration like this. Here water will be removed from the compound. Dehydration means removal of water. So in case of tertiary alcohol, instead of dehydrogenation, dehydration takes place when you apply copper and you apply 573 Kelvin temperature. Thank you.